In the first chapter, we have already discussed about what is a capacitor. Capacitor is a voltage storing device. It is a passive component. We have discussed different passive components: resistors, inductors, capacitors. We discussed capacitor can store the DC voltage. Capacitor acts like a short circuit for AC voltage. In the capacitor we have fixed capacitors and also we have variable capacitors. In the variable capacitors we have discussed tuning capacitors, varactors, trimmer capacitors, different types of variable capacitors we have discussed. But as an electronic student, as an electronic engineer, as an electronic scientist or an electronic researcher, why can't we use a semiconductor material for the capacitor? We have discussed we are using the semiconductor material to emit the light. That is what we have called LED. That replaced the entire conventional bulbs. Now we are thinking, we are taking a bulkier capacitors. We have these tubular capacitors. They are very much bulky. But in our phone, you can see the device is very much compact. The electronic devices are becoming compact. We require a very less size capacitor. Sir, very less size capacitor, we require dielectric material. We require two metallic plates. A metallic plate with the dielectric we require to form the capacitance. How it is possible without metallic plates? Because two metallic plates are required and the dielectric material is required. So without this combination, how we can form the capacitance? Then we are saying no need to worry. We have discussed about the semiconductor devices. We have discussed about the semiconductor diode. We can use as a diode as a capacitor. If we use the diode as a capacitor, a small teeny PN diode can be used as a capacitor. In place of one tubular capacitor, you can use many teeny PN diodes. That's what we are discussing now. The topic name is Varactor diode. Varactor, variable capacitor. Varactor. It is a diode because it is a PN junction diode. It is also called as varicap because it is a variable capacitors. Whatever the capacitance you want, by using this diode you can change. How the diode is working like a capacitance, we will check that. We discussed LED should be always connected in the forward bias. Here the varactor diode should be always, it should be operated in the reverse bias only. It should be always connected in the reverse bias. Sir, why we are connecting only in reverse bias? What happens if we connect in the forward bias? If you are connecting in the reverse bias, when you are changing the voltage with the increment of the voltage, the depletion region width increases. What is this depletion region? We have already discussed. In the N side, we have immobile positively charged carriers, and on the P side we have immobile negatively charged ions. Because these are the ions, but they are not able to move. If they are able to move, then there is no problem to us. This is not an insulator then. But these are the ions. They are having the charge, but they are not able to move. This is a positively charged ion, but it is not able to move. This is a negatively charged ion, but it is not able to move. If those ions are capable to move, then they will provide the current. Because they are not moving, they are not providing the current. So this region, even though we are having the positively charged ions and negatively charged ions, because they are not providing any amount of electricity to us, this region is acting like an insulator. This insulator is nothing but the dielectric material we discussed in the capacitor. In the capacitor we discussed, the capacitance can be formed by using two metallic plates, and we have to use a dielectric material in between these metallic plates, then the capacitance is formed. What is this dielectric is doing? This is storing the electric field lines. The electric field lines can penetrate through the dielectric material. The electric field lines can penetrate through the wood. The electric field lines can penetrate through the wall. So we are using the dielectric material. So this dielectric material can be used to store these electric field lines. We are using the two metallic plates here to store the charge, to store the electric charge, to store the voltage. We are using the two metallic plates and a dielectric material. Here, this capacitance we are trying to replicate by using the semiconductor diode. This is what we are trying to do here. That's why it should be always operated in the reverse bias. When we are operating in the reverse bias, P-type semiconductor should be connected to the negatively charged terminal of the battery or the negative terminal of the battery, and the N-type semiconductor is connected to the positive terminal of the battery. Then this diode is said to be connected in reverse bias. Now if we are increasing the voltage, then the depletion region width increases because these electrons are moving towards the positively charged terminal of the battery. So these ions, the depletion region width is increasing. Similarly, holes also, the depletion region width is completely depending upon the battery. The applied voltage when we are increasing, the depletion region width is increasing. When the depletion region width is increasing, then the ability to the minority charge carriers here already they are traveling because it is connected in the reverse bias. How the minority charge carriers are formed in N-type semiconductor? Because of the thermal energy. How the minority carriers electrons are formed in the P-type semiconductor? Thermal energy. In the N-type semiconductor, minority carriers are holes. In P-type semiconductor, minority carriers are. So these minority carriers are moving, but this current is not relevant to our topic. Our topic is only capacitance. We are seeing this as one metallic plate, and this as one metallic plate, and this as a dielectric material. So P-type semiconductor is acting like one metallic plate. N-type semiconductor is acting like one metallic plate, and this depletion region is acting like a dielectric material. So the capacitance can be formed now. Because we require only two metallic plates and a dielectric material to form the capacitance, P-type semiconductor and N-type semiconductor are saying we are ready to act like metallic plates. And the depletion region is saying I am also ready to act like dielectric material. Now we have to vary this capacitance. What is the capacitance? C is equal to epsilon A by D, where epsilon is nothing but permittivity. Permittivity means we are checking this material, this dielectric, electric field lines, how it can allow the material, the ability of the material to allow the electric field lines through it is given by using the epsilon permittivity, where A is the area of the PN junction and D is the distance between the two plates. Here the depletion region width. So here D is nothing but the width of the depletion region. We cannot change the epsilon because the semiconductor material is fixed. We cannot change the area because the PN junction is fixed. The cross-sectional area is fixed. What parameter we can change? We can change the distance between the plates. We can change the dielectric width. We can change the depletion region width. How we can change? By changing the reverse bias voltage. With the increment of the reverse bias voltage, the depletion region width is increasing. When the depletion region width is increasing, then capacitance is decreasing. This capacitance can be changed by using the reverse bias voltage. Voltage variable capacitor. When we are changing the voltage, we are changing the capacitance. Voltage. Now the capacitance is in the control of voltage. That's why it is called as voltage variable capacitance diode. That is the real meaning. We have discussed already the capacitor can, by changing the capacitance, its ability to store the voltage changes. But the real meaning comes here. By changing the voltage, we are changing the capacitance. Remember this point. By changing the voltage, we are changing the depletion region width. That's why it is called as voltage variable capacitor. What factor you are varying voltage? With the varying of the voltage, what factor is getting affected? Depletion region width. By changing the depletion region width, you are changing the capacitance. Now the name VariCap, variable capacitor, its capacitance is varying. Now it is our control and it is a semiconductor device. We can proudly say we have replicated the capacitor. We have created the capacitor. We have made the capacitor by using the semiconductor diode. So there is no need for us now to use the conventional capacitor. We can use even our semiconductor diode as a capacitor. P and N regions, they are acting like conductors, we have discussed, and the depletion region is acting like a dielectric. Now this capacitance is called as transition capacitance, and this capacitance is also called as barrier capacitance and depletion layer capacitance, junction capacitance, space charge capacitance. All these names we have discussed. Potential barrier, space charge region. With respect to those names, we are calling this, whatever the name we may call, but the final term we are giving to it is capacitor. So this is a variable capacitor. Here we are drawing the circuit symbol of Varactor diode. This P-type arrow represents the P-type semiconductor. Vertical bar represents the N-type semiconductor. These two terminals are representing capacitor and the arrow is representing variable capacitor. We have already seen the circuit symbol in the first chapter for the variable capacitor. Diode in combination with the variable capacitor, this is the circuit symbol for the Varactor diode. In the place of the diode, here we are drawing the electrical equivalent circuit symbol. Electrical equivalent circuit symbol, when the diode is connected in the reverse bias, what is its resistance? RR. And when the diode is connected in the reverse bias, here we are showing the variable capacitance. So this is the electrical equivalent circuit symbol of Varactor diode. Here you can see, with the increment of the reverse voltage, the capacitance is changing. The maximum capacitance and the minimum capacitance by changing the voltage. Why we are drawing this diagram in the second quadrant only? Because the voltage we have supplied is the negative voltage. By changing the negative voltage, you are changing the capacitance. The more negative voltage you are giving, the minimum capacitance you are getting. The capacitance is in the control of the voltage. and we are drawing that in the second quadrant. What are the advantages of this Varactor diode? We have discussed size. In the place of the conventional tubular capacitor, one tubular capacitor, many PN junction diode capacitors can be used. So it is the very advantage to us, because now we want very compact devices. Nobody wants board size mobile. In the starting days when Charles Babbage, or in starting days when they made calculator, they have to give the inputs from one room and they have to take the output from the other room. Assume that type of calculator when you are giving in the input in one room and you are taking the output from other room. That type of calculator they have started, and now we have ended with the pocket size calculators and watch size calculators. We are trying to make the devices very compact. Size is very much we are trying to reduce. In this scenario, instead of normal capacitor, the PN junction capacitor is very much useful to us, because it is making the size very much compact and very much lesser. And it is operating over the wide range of frequencies. The normal capacitor, by using a normal capacitor, we can change the frequencies only in the narrow range. But by using this capacitor, we can change the frequencies in the wide range. Wide range you can change the frequencies means by using this capacitor you can change many channels. Sir, I want one channel, I want the news channel, I want the sports channel, now I want the another movie channel. You can change the hundreds of channels by using the simple PN diode, because its operation is over the wide range of frequencies, and the response is very much faster. When you are changing the voltage, immediately the capacitance is being affected. In effect with that capacitance, the frequency will also change. The fast response is another advantage to us. So these are the advantages of the Varactor diode. So we have started our topic. Varactor diode is a variable capacitor. What is Varactor means? Variable capacitor. It is a diode or it is a transistor. Whether it is a diode or transistor? Diode. PN junction diode. We are calling it as a varicap because it is a variable capacitor. Volt cap. Why we are calling as a volt cap? Because by changing the voltage, we can change the capacitance. The more reverse voltage you are giving, the minimum capacitance you are getting. The change of the voltage is affecting the capacitance. Voltage is affecting the capacitance. That's why you are calling this as volt cap. And you are also calling this as a voltage variable capacitance diode. Voltage variable capacitance diode. With the variance of the voltage, you are varying the capacitance. That's why it is called as voltage variable capacitance diode. It is also called as tuning diode. Tuning diode, and because it is a capacitor, you can even call that as a tuning capacitor. It should be always connected in reverse bias. That's why we have shown even the voltage in the second quadrant. The depletion, now you can see here that this is the conventional capacitor. We require two metallic plates. Where are those two metallic plates? One is P-type semiconductor, second one is we require a dielectric material. Where is the dielectric? Depletion region. Depletion region is saying, I am there, no need to worry. Instead of the normal dielectric, I am acting like a dielectric. Because here no free charge carriers are there. Sir, ions are there, but those are immobile ions. If those ions started moving, then there is no concept of insulator here. And there is no concept of depletion region. Then there is no concept of diode. Then there is no concept of variable capacitor or Varactor diode. Because these ions are not moving, this region is acting like an insulator. Okay? C is equal to epsilon A by D. Epsilon means permittivity. permittivity of the medium fixed because we are using the same. What is the material here we are using? Semiconductor or conductor or insulator? Semiconductor we are using, but that is behaving like a insulator. Even though we are using the semiconductor at the depletion region, because of the no free charge carriers, only immobile positively and negatively charged ions are there from the both sides. It is behaving like insulator. There is no current from here. Okay? And what is a area of the PN junction? D, distance between the plates. Here distance between the plates means depletion region width. How the depletion region width is being affected? Voltage. With the increment of the voltage, reverse voltage, depletion region width increases. When the depletion region width is increasing, the capacitance is decreasing. Then you may get the doubt. It is decreasing, but I want some mathematical proportionality with the voltage, how much capacitance is changing. We already discussed that is in the inversely proportional format. So the capacitance of this PN junction diode is inversely proportional to V to the power N, where N is the doping density, V is the applied reverse voltage. The actual equation is 1 plus V by forward voltage drop to the power N or reverse voltage drop to the power N. But finally we are condensing that equation and we are saying the capacitance is inversely proportional to a reverse voltage to the power neta. This is a doping density. This depends upon the semiconductor material. This is separate for germanium and semiconductor. Germanium semiconductor and silicon semiconductor. Okay, so this is constant and this depends upon the doping density of that semiconductor. And this is the applied reverse voltage and this is the PN junction capacitance. Here, what is this arrow symbol is representing? Variable capacitor. We have mixed the diode symbol and variable capacitor symbol and we called this as a Varactor diode. Electrical equivalent symbol in the reverse bias, the diode we are representing with the resistor, that is reverse resistance, and this capacitor. In series we have connected. This is the electrical equivalent circuit of the Varactor diode. Advantages we have discussed. Now we are going for the applications. Tank circuit. Whenever you are seeing antennas, whenever you want to design antenna, then you call Varactor diode. Varactor diode, please come. I want to design antenna. In the second year, you will learn 1 by 2 pi f is equal to 1 by 2 pi root LC. That is the frequency of the tank circuit. You are not changing the inductance, but you are changing the capacitance. By changing the capacitance, you are changing the frequency. The antenna frequency you can change. You can design the antenna, your own antenna. But to transmit any signal in the other than the broadcast range, you have to require permission. Okay, so we can design the tank circuits. Even in the oscillators, you will learn in the second year. In oscillator circuits also, we use the tank circuit. In those tank circuits, we can use this Varactor diode. So automatical frequency control also, you can use the Varactor diode. In the frequency modulation, you can learn in the second year. Amplitude modulation, frequency modulation, phase modulation, these topics you will learn in the second year. In the frequency modulation receivers, FM receivers, radio receivers, TV receivers, we can use the Varactor diode. By changing the remote, you can change the channel. But in reality, the capacitance is being changed. By using the Varactor diode, you can change the capacitance. By changing the capacitance, you can change the frequency. Means you are changing the channel. And you can use it in adjustable band pass filters. what is low pass filter, what is band pass filter, what is high pass filter. These concepts you will learn in the second year. You use in logic memory storage device. We discussed capacitor is used as a voltage storage device. So you can use it as a logic memory device. You will learn this in second year digital electronics. It is used as a voltage controlled oscillator. We are controlling the capacitance by using the voltage. So voltage controlled oscillator. By using the voltage, we are changing the frequency. How we are changing the frequency? When we are changing the voltage, capacitance is being changed. When the capacitance is being changed, automatically frequency is being changed. That is called as voltage controlled oscillator. You will learn in the second year. And in frequency multiplier, when two frequencies you want to generate and those two frequencies you want to multiply, at that time you can use the Varactor diode. These are the applications of the Varactor diode. One small semiconductor diode is capable of behaving like a capacitor. It is capable of behaving like a capacitor, that is a variable capacitor, and that is in our control. By changing the voltage, we are changing the capacitance. There is no need to design the capacitors particularly with the different sizes. The capacitance value is in our hands. By changing the voltage, we can change the capacitance. This is acting like a diode, and this is also acting like a capacitor. That's why we are calling this as a Varactor diode.